Hello to all, my name is Sergey Prilutsky, and today we'll continue our talks about the algorithms used in blockchain applications. Today we'll talk about the peer-to-peer networking. The peer-to-peer networking is a very important set of algorithms in decentralized networks. The peer-to-peer networking allows us to distribute the information between many hosts in network. Okay, let's talk how works the basics of these protocols. Okay, when we say I send the transaction to blockchain, where exactly I send my transaction? Which computer accept the network packets from my computer? And this is the most interesting question. In the peer-to-peer networks, there are many independent nodes, many independent computers, and the protocols are built to keep the copy of important information on the hosts which are closer to the requesting computer. For example, if I request some information, some file for example, I just send my transaction to any node. To this node, to this node, or to this node. I already have a list of these nodes on my computer, but I can update this list and keep it up to date with the information received with each request. When I send a request to the node number 2, the node number 2 can say me, I have no file, but I know another node who might know. For example, this is node number 3. And the next request I made to the node number 3. And I remember that node number 2 told me about the possibility of existence of data needed on the node number 3. The most interesting part of these protocols is the algorithm of choosing the nodes and how the nodes exchange the information about the data they store. The first you must understand is the fact that in decentralized network we can address the data only by its content. It doesn't matter how we name our file. For example, it can be Oleg .doc or Vasily .doc. It doesn't matter. For us, the only important information is the contents of this file. And we want to know if the two files with the same name has the same content. For this purpose, we use the hashing, the cryptographic hashing. We've already spoken in another video. So every part of data in decentralized network is addressed by its hash. For example, if we have some file, we just can ask for its hash. So we send the transaction to the decentralized to peer-to-peer network, asking for some hash. The second important part of peer-to-peer protocols is the distance metric. Distance metric is a number who measure the so-called distance between two different nodes. And every time we ask for some data and this data is not stored on a particular node, this node says us the address of next node who may have this hash. And this node chooses the shortest distance between asking node and the node recipient. In different implementation of this protocol, the node can choose the distance using the IP address, network availability, and some useful metrics because the asking node wants to receive its data more faster. In other implementations, this distance is simply synthetic, made cryptographically, so the average file is distributed along all the networks. Another important thing to understand is the caching of data on the intermediate node. For example, if my asking computer already asked for some data on the node number 2, the node number 2 answer me with the next node number and also receive a part of data and stores it into its storage. So the next time I ask for this file, the node will give me the data directly without going to another node. With such a way, every popular file, this is a file that is requested by many requesters, is spread along almost all network. So, for example, if it's a new video, the first time it's stored only on one node. With the next request it's stored on 2 nodes, on 3 nodes, 5, 10, 1000. It depends on the amount of requests to this file. Such an architecture allows the peer-to-peer network to transfer a huge amount of files. The best primer of such a network is a BitTorrent network. Now the traffic of the BitTorrent network is a very big part of all internet traffic. It's much more than all cloud storage of big cloud data providers. Okay, when we talk about the peer-to-peer implementation in blockchain, it means that we have 2 entities we need to spread across all the networks. We have a pack of nodes who produce blocks, who receives the transactions from the users and produce blocks. We call them miners, for example, in the Bitcoin network. The miners want to receive actual transactions from users, and users want to download the new version of blocks from the network. The best solution for this is, and the only possible solution to accomplish this task, is peer-to-peer networking. So every time when our wallet software forms the transactions, we already speak about it in the video with the digital signature, we sign it with our secret key and we send this transaction to the peer-to-peer network. Sending to peer-to-peer network, it means that then we send this transaction to the first node we know, for example to the node number 1. It records our transactions and it tells to other node that it has a new version of the transaction. Then the first node sends the transaction to third node and it adds it to its list. In response, the third node gives to nodes number 1 its new transactions. So all the network keep a one version. This is a kind of a ledger of new transaction and processing. Then, using this ledger, every miner can take any part of this transaction and form a block. Then, when some miner form some Bitcoin block, it wants to spread it across the network because the block he wants the block to be accepted by the whole network, and it also uses the peer-to-peer networking algorithms to spread its block to all the network. It's very fast, and now this network works with a great speed, because when one node begins to download some data from one node, it can in parallel begin to download other part of block, for example the second part of block, from another node, and the downloading process can be very faster. Talking not about the transactions and blocks only, but talking also about arbitrary files, we cannot avoid the IPFS. Somebody thinks that IPFS is some type of a cloud storage, that I can upload a file and the network will keep this file for me. This is wrong. IPFS, this is a protocol. This is a peer-to-peer protocol allowing the nodes to distribute some file between them. but only in case if somebody continuously requests this file for network. If I have some file and I upload it to IPFS, it is spread in the network, and different parts of this file are kept on different servers in the network. But when anybody asks for a file and begins to make a request to network, where is the parts of my file, the networks begin to cache this file on the nodes, and in a short time the copy of this file is available on every node. But in case if you've uploaded some personal file, the file that is requested only but you, the network is not incentivized to keep this file, and these parts of it will be thrown away in some after a little time, because nobody wants it. There is no request seeking these parts of file, and every node will just forget these parts because nobody wants to download them. So we cannot consider the IPFS as a cloud storage. You are still responsible for the keeping of your files. So, but you can upload it to network, and be sure that even if the million users want to download your file, you will not have the problems with the scalability or bandwidth for downloading your files. So it's a good way to store a big and popular files. That was a short explanation of peer-to-peer networking. See you in next video. Bye.